Tonight's video lesson is on thermodynamics. This is going to introduce us to our last topic for this course and start you on your coursework for biology. We're going to start with thermodynamics and eventually we'll move into biochemistry. The objectives for tonight's lesson here is that I can explain the difference between an exothermic and endothermic reaction. I can also explain a reaction coordinate. The last thing you should be able to do is provide examples of endothermic and exothermic reactions in real life. The chart above here I have provided a side-by-side comparison of endothermic and exothermic reactions. An endothermic reaction requires additional heat to take place. These are chemical reactions that without you providing some additional energy, they're not going to take place. For example, if you take a piece of chicken out of the freezer and leave it on the counter, it's not going to cook. You need to add heat to it. Okay. What's going on in an endothermic reaction is that you are breaking chemical bonds, and this requires energy to take place. For example, we have cooking chicken, cooking pasta. These are both examples of endothermic reactions. An exothermic reaction, on the other hand, gives off heat as it takes place. All right, so in this case, you're forming chemical bonds, and this is releasing energy. For example, photosynthesis is an exothermic reaction. As sugar is formed in plants, it has to give off heat. Okay, and these reactions will take place on their own. And so, for example, we have combustion of gasoline. Once you get it started, it is an exothermic reaction. It gives off heat. Okay, reaction of hydrochloric acid and zinc. Exothermic. When you add the hydrochloric acid to the zinc starts to form zinc chloride, and it gives off hydrogen gas and heat. The next part of tonight's lesson here is I'm going to draw what's called a reaction coordinate, and you're going to see some of these over the next few days here in the class. And basically what a reaction coordinate is, this is a reaction that shows how the reaction takes place. It's a graph basically. So we've got our reaction coordinate. Y-axis here we have potential energy. Oops, if I can write here. All right. And so what a reaction coordinate does is it tracks the progress of a reaction as it takes place, and generally looks something like this. And so at point 1 on the graph, this is your reactant. So, for example, when you put gasoline in your car engine, that's the reactant, okay? And what this hill here is called is, or point 2 on the graph, is what's referred to as the activation energy. Alright, so how much energy does it take for that reaction to take place? All chemical reactions require energy to do it. Alright, it's just a matter of how much. If it's got a low activation energy, it'll almost happen as soon as you put the chemicals together. If it's got a high activation energy, you might have to do additional work. And then part 3 on here is the energy of the products. Now, if the energy of the products is below what the initial energy was of the reactants, then this is what's referred to as an exothermic reaction. Because now we've got less potential energy than we did when we began, and so this means that we're giving off heat. If the end result here has a higher amount of energy, so let's say, for example, where I draw this red line in here, if this was the energy of our products instead, that would be referred to as an endothermic reaction, because after the reaction took place, there's now more potential energy, which means that heat had to be added to the system to get the reaction to take place. And it's being stored now in order for future reactions. We're almost to the last part of this video here where we talk about conservation of energy. One thing that's important to remember is in any chemical reaction, you have to conserve energy. So energy cannot be created or destroyed. It can only be changed. So when we're talking about heat and potential energy and kinetic energy, whatever you put into the system has to be accounted for when it comes out. All right. So an exothermic reaction has to give off that extra energy as heat. An endothermic reaction requires energy to be inputted into the system. Heat is a form of energy. You may commonly refer to as heat as temperature, and temperature is a measurement of the kinetic energy for a set of molecules. It is not the same thing as heat. Okay? Additional heat provides more kinetic energy for molecules, but it does not directly equate to temperature.